Okay, so this is lesson 1 of the 5.3 chemistry year 11 topic, which is reactivity series and metals and their extractions. So today we're going to be focusing on the reactivity series. So you need to write down your own date. I just realised there's a random date. Okay, reactivity series is the title. Then we've got a learning objective and our keywords. If you're using your class notebook, this will already be in, but if you're writing on paper, can you make sure you write down date, title and keywords as though you were in a lesson? So the nodder words today: to recognise that metals are found in ores and explain their difficulty of extraction using their position in the reactivity series. Remember, keywords really important for your scientific literacy. And to get you started, I have put your class notebook, I've put a periodic table, but you can just Google WJC periodic table if you're unsure. And I would like you to find the metals. What do we remember about metals? Metals tend to be group 1 and group 2, and then all that bit in the middle, they're the metals. So in here is the PB or the S, the metal. Have a think. Pause the screen, write down your answers, and I'll be back in a minute with the answers. Okay, so with this one, PB, which stands for lead, that's the metal. This one, zinc, again the metal. This one is iron, that's the metal. That one is iron as well. And then this one, copper, they're the metals. Okay, ores is just what a metal's attached to. If you notice, the metal tends to come first. Okay, so I hope you got all of them right. Give yourself a mark out of 5 if you got them all right. Like I said, we're going to recognise that metals are found in ores. So that's metals attached to non-metals, and explain how we extract them. So there are a couple of key definitions that you need to know. So I want you to note these down and start remembering them. The first one is extraction. Extraction means removing a metal element from a compound to form a pure metal. Okay, so such as removing iron from iron oxide, just be careful, the numbers haven't come out quite right on the PDF, to form a pure metal. Iron, obviously, we use in bridges and other large structures, so we don't really want it attached to the oxide, but that's how it's normally naturally found, so we need to extract it. So that's the first key definition. Next key definition is what an ore is. This normally comes up for a 1 mark, so it comes up quite a lot for 1 mark. So ores are minerals from the Earth's crust that contain metal compounds. Metals are extracted from these ores, okay? So the Earth's crust is the bit that we stand on. It's the thinnest bit, but it contains the most useful things to us. So remember from last year, then the mantle's below it. But what we do is we mine and extract ores from the Earth's crust. That's where we find the majority of the metals that you use every day. And then finally, key definition number 3, reactivity. Reactivity is a measure of how readily and volatile a substance will react with another substance. We did a little bit of this in the acids and bases topic, but we're going to move on now and do a little bit more. Again, note down this key definition because you need to learn it. 1 mark answer if it comes up. So this is the reactivity series again. We've done a little bit of this when it came to metals and in the acids and bases topic. So like we've just discussed, reactivity is a measure of how readily a compound will react with another. Okay, how fussy it is. The ones at the top are really reactive. So potassium, sodium, they're in group 1. We did them last year and how they can't really even be stored in air because they react. So the more reactive a metal is, the harder it is to extract. So it doesn't like to be removed from its ore. It likes to be bonded. Okay, they love to be bonded to other elements than on its own. Gold is very fussy, so we'll write down the bottom. It doesn't react with anything, whereas potassium wants to react with everything, okay? It's unlikely they'll ask you to list them, but you kind of need to get a feel for where each element is and how it's extracted. So come up with a little rhyme. Please stop calling me a careless zebra. Instead, try learning how copper saves gold, okay? Start trying to remember that because you need to know where they are in the reactivity series. Okay, so a couple of review questions. I don't know what's happened there, but that's the most reactive one at the top and that's the most least reactive at the bottom. Okay, so thinking about what I just said, pause the video and answer these two questions. Okay, which are the hardest? The ones at the top, such as potassium and sodium, they're so reactive, they're quite hard to extract. The easiest ones are then your golds and your silvers. They're not very reactive, making them easier to extract. Use your reactivity series to explain why wedding rings are made of gold and not magnesium. Well, gold's very unreactive. So you want to be thinking about it reacting with water if you're washing your hands, or reacting with the air. Okay, magnesium it reacts quite slowly with water, but it still does react with water. So you can't imagine your wedding ring every time you wash your hands. So that's why we use gold and silver. And you can get jewellery with copper in it because they're so unreactive. They won't react with the water and the air, making them a useful piece of jewellery. Next key definition again. So again, you need to learn it. This is one that we did a little bit of last year when we did Group 1 and Group 7. However, you need to learn it again. So displacement, when a more reactive element takes the place of another one in a compound. So the more reactive element displaces the less reactive element. And we're going to look at a couple of examples of that now. So just to put it into context of maybe, I'm sure you all know about how Brad and Jennifer Aniston were married to each other, and then they worked on a movie together and Angelina Jolie came along. So Angelina Jolie was more reactive than Jennifer, and then she stole Brad away from Jennifer. So the more reactive element, we say, steals away the other part of it. Okay, this doesn't really work out anymore now because Brad and Angelina are split up, but that was just the key one that we tend to use. And then for your Love Island fans out here, this was about 2 seasons ago, but the same kind of thing. Georgia and Josh were together. Kaz comes in, she's more reactive than Georgia, so she steals away Josh from Georgia. Okay, and then that leaves Georgia on her own. Okay, I'm sure you could come up with loads of your own definitions of that. We're now going to relate it to elements. So we've done a little bit of a fun bit whereby we relate it to the bigger picture, thinking about relationships, and we're going to relate it to metals. We extract metals from compounds by using more reactive elements to displace the metal. Okay, so that's how we kind of extract certain metals. So here are a couple of examples. Okay, it might be quite useful for you to have the reactivity series. Okay, so you've got it in your class notebook, or it might be useful just to write down the rhyme to help you remember. So what we're looking at is that the more reactive element will displace the less reactive element. So we've got zinc and iron. So zinc is here, iron is here. They're quite close, but zinc is more reactive. So I'm just going to write it like that, more reactive. Iron is less reactive. Okay, so what we do is we add the zinc to the iron. The iron's attached to a non-metal compound. What will happen? The zinc is more reactive. It's going to steal away that non-metal bit, and you're going to end up with iron on its own, and you can use that for loads of things. Remember I said about making bridges, so that's perfect for us because we want iron on its own, and then you end up with zinc sulfate. Okay, that's all that happens. Next up then, you've got copper and sodium. Look in, there's sodium. Ooh, copper's all the way down here. Okay, so this one is more reactive. So copper will not be able to steal away that non-metal section. Okay, so there's no reaction. There should be arrows here, but something's happened. Last one then, you've got sodium and silver. Silver's all the way down here. Sodium's at the top. Sodium's more reactive. So it's going to steal away the nitrate, the non-metal bit from silver. So you end up with silver. We can use that to make rings, other jewellery. Perfect. And then you end up with sodium nitrate. Okay, that's just a couple of examples. What I'd like you to do now is finish off these word equations for me. Okay, again, pause it. Just finish them off, and I've put the reactivity series by there. Okay, so the first one then, potassium is more reactive than calcium, so you'll end up with potassium oxide, so it'll steal away that oxide, the potassium, because it's more reactive. And then you've got calcium on its own, which is perfect for us. we can use it for all examples. So remember, these are likely to have been extracted from the earth, coming out in an ore, but we want calcium on its own. Okay, iron and sodium chloride. Iron is here, sodium's up here, so unfortunately there'll be no reaction. Iron is less reactive than sodium, it's not going to displace it. Copper and silver nitrate. Copper's there, silver's there, so copper's more reactive, so copper's going to steal that nitrate away, and you're going to end up with silver on its own. Okay, then magnesium and gold. Straight away you should know that one. Gold's the least reactive element right down here, whereas magnesium's up here. So magnesium's going to steal away that fluoride and end up with magnesium fluoride plus gold. Okay, so that's nice and easy. And then I want you to, and I've put a little video on you on the Teams for you to watch. Okay, little video of the thermite reaction is exactly the same thing. Okay, thermite is the reaction between iron oxide and aluminium. Okay, so look at your reactivity series. There's aluminium, there's iron, so you should already be able to work out what is going on here, but watch the little video. Okay, it's quite an impressive reaction, and try and fill in the words on your sheet, or write it out if you don't have a sheet, using the information provided. Okay, like always, if you've got any issues, email me.